DNA polymerase only catalyzes the synthesis of a new DNA chain in the 5' to 3' direction. The reason for this is that new DNA nucleotides must approach the elongating chain with their 5' end first. It is this end that has the triphosphate bond, which will serve as the energy source to create the new bond, uniting this nucleotide to the existing chain. Because the new nucleotides approach with their 5' end first, and thus this high energy bond, if a mistake was made, if an incorrect nucleotide was added to the chain, it could be removed and a new nucleotide could come because it would also then approach with its 5' end and the high energy bond facing inward to form this chain. So therefore, mistakes can be corrected and as many new nucleotides can be inserted as needed because all of them will approach with the high energy bond which will be used to make the new bond. In contrast, if new nucleotides approached the existing DNA chain with their 3' end facing the chain, then a bond could only be made once because the high energy bond, which would be the source of the energy, would be the existing nucleotide already joined to the chain. If an incorrect nucleotide was added and then removed, then a new bond could not be formed because the existing nucleotide would have already used its triphosphate bond, and the new nucleotide would be approaching with its 3' end first that does not have a triphosphate bond. And so DNA polymerase could not catalyze the synthesis of a new chain in this direction because it would not allow for the correction of incorrect base pairing.